So yesterday we talked about a couple environmental issues. We talked about acid precipitation caused by sulfur and nitrogen in the atmosphere, which form acids, which lowers the pH of the rain and snow and so forth, which leads to damage to ecosystems. We talked about smog, the buildup of toxic gas at ground level, which is harmful to lungs. Two more issues we'll talk about today: ozone depletion and climate change or global warming. So ozone depletion is an issue that has to do with a layer of gas very, very high in the stratosphere, the very outer edges of the Earth's atmosphere. There's a layer of ozone gas, which is very important. Does anybody know what this ozone gas does for us? Jack?
Ultraviolet rays.
Yeah, it filters out a significant portion of the ultraviolet radiation found in the sun's energy. Okay. And that's important because what are the effects of ultraviolet radiation? What?
Extreme heat.
What?
Extreme heat.
No, it doesn't have to do with heat. Luke?
Skin cancer?
Yeah, the ultraviolet rays are damaging to living organisms. Ultraviolet rays are what cause you to get a sunburn. Exposure to ultraviolet rays increase one's risk of cancer of the eye and skin cancer, melanoma. Luckily for us, the ozone layer blocks a significant portion of that. We still get sunburns, okay, and exposure to that can lead to an increased risk of skin cancer, but there's much less reaching us because of this layer high in the atmosphere of ozone. The problem is that there are chemicals that humans produce called fluorocarbons, CFCs, that make their way into the upper atmosphere and eat away at this ozone layer. They destroy the ozone layer. These gases were once commonly used in aerosol cans, like if you imagine like spray paint or shaving cream or hairspray, something like that. Those pressurized products have a propellant in them that makes the stuff come out. That used to be made of CFCs. And so if you're putting on your hairspray in the morning and spraying that, the hairspray stuff's going in your hair, but these CFCs are leaking out. They eventually make their way in the upper atmosphere, and they start to eat away at the ozone layer. Okay? And what that means is the ozone layer doesn't do its job as well. It cannot filter as much ultraviolet radiation out as it used to. Consequences of this: increased risks of skin cancer, eye problems. This especially became a problem over Antarctica. That's where these gases sort of concentrated and where there's actually a hole in the ozone layer, where there was none of the ozone layer left in that area. So what would be a possible solution to this sort of a problem? Produce more ozone? That's one idea. Not really. But I said it's an idea. That would make sense, right? You can produce more ozone from the atmosphere. We don't really do that. Yeah, we can reduce the use of CFCs, and we did that. Back in, I believe it was 1987, there was what was called the Montreal Protocol, where countries from around the world came to an agreement to limit the use of CFCs. Today, that bottle of hairspray or shaving cream does not have CFCs in it. Okay. So if you use hairspray, you're not damaging the ozone layer. And so they sort of limited the use of CFCs. They're still used in certain things. Air conditioning, refrigeration, uses a gas called Freon in it. I don't know if you've ever heard of that, but that's also an ozone depleting chemical. So if you go to like, if you have a car and your air conditioning is not working very well, you may have a Freon leak. You may have a leak in your air conditioning system where this gas leaked out, your air conditioning doesn't work. And they may recharge it, put new gas in there. And nowadays, they capture any remaining gas from your air conditioning unit and store it away instead of just releasing it in the atmosphere. And so there have been improvements in the composition of the ozone layer over time since we've started limiting our use of CFCs. So some of these problems can be addressed, but they take sort of global efforts by lots of countries sort of getting on the same page and agreeing to address these issues.
Is there any way to restore the ozone layer?
Not really. No, there's not a real way to like replenish that ozone up in the higher atmosphere. Do it?
What is the ozone layer made of?
A form of oxygen, O3. That's what ozone is.
Okay, so how did it get a hole in Antarctica if there's like no one living there, so there's no like CFCs?
Because these gases, they get in the upper atmosphere, they circulate around through air currents, and even though they're released in North America or Europe, they move through the air and eventually end up there. It takes a while for them to get up there, but because of air currents. All right, and our final environmental issue to talk about is global warming or climate change. They are kind of mean the same thing. Climate change is sort of the more modern term to use than global warming. But as you guys told me, global warming is caused by the accumulation of CO2 in the atmosphere, carbon dioxide. And the vast majority of this carbon dioxide comes from the burning of fossil fuels. Sometimes people feel like, oh, it's because of humans, there's so many humans breathing out CO2. That's not what is causing this. The cause is mainly burning of fossil fuels. Anytime you burn oil or coal or natural gas, part of the byproducts of that is carbon dioxide. And as you know, because we have so many cars and factories and utilize so much of these fossil fuels, we release huge amounts of carbon dioxide into the atmosphere. And so what carbon dioxide basically acts as a blanket over the earth. And so the thicker that blanket, the more carbon dioxide there is, the more heat it tracks. We'll talk about that in a minute. Since 1850s, carbon dioxide has increased dramatically. So what do you know from social studies?
Industrial revolution.
Industrial Revolution. Pre-industrial revolution, humans did not burn large amounts of fossil fuels. We would burn wood and so forth, and some coal and things that was taken out of the ground for like personal heating and cooking and stuff, but not huge amounts. But since the Industrial Revolution, factories, machinery utilized fossil fuels as their source of energy, and therefore that led to the increase in carbon dioxide. So, I don't know, it's nice. A lot of people like warm weather. So what's wrong with global warming? Why are we so concerned about it? Okay? Let's give me one.
Eventually, like, and this is gonna take a while, but it may get to such extreme heat that we cannot survive there anymore,
Okay.
and then have to kill us off.
Probably, levels would not increase probably that much. So there would be more data because projections are for, 2-3 degrees Celsius increases in global temperature over, a fairly long period of time. So that wouldn't be like hot enough that we couldn't survive, but it could change things that would make things much more difficult. Such as what? Okay. Okay. Increased droughts because of the overall global temperature is hot. Dry areas would become drier. Okay. Areas that once were had adequate water may no longer have adequate water. You may have the increase in the amount of deserts. What else? What almost the opposite of it? Sophia? Go ahead. You're gonna say something.
It could like harm like the ecosystem.
Yeah.
Like their habitats would change.
Perfect. Yeah, so organisms are adapted to certain climates, certain conditions. If those conditions change, the species that live there currently may no longer be able to survive because of climate change. Certain species are moving northward because they were adapted to warmer conditions, and as the entire Earth warms up, they move northward. certain types of insects that carry disease, mosquitoes and so forth, that used to not be able to survive certain areas. Now they can survive in those areas because they're warm enough for them. We talked about the Anopheles mosquito, which requires heat for part of its life cycle, and generally it was confined to tropical areas. Well, if the entire globe is heating up, that means the range of that Anopheles mosquito can expand.
Wouldn't the earth get like flooded because the ice caps melt?
As the earth gets warmer, the ice caps and glaciers melt, and that water goes into the oceans. That increases sea level, which can lead to flooding with many areas.
I saw this thing, and it said like, in 2000, like, 300, like, New York City will be gone.
I'll show you some pictures in a minute that are interesting, related to that.
Like, I don't know, like, but like one time, like my dad told me, like he doesn't understand, like if like ice caps, like glaciers, like melt, like he doesn't understand how it would like flood like North America because like they showed me this experiment where like say you put like a block of ice into a bucket of water, and water level increases, but even if the ice melts, the water still stays the same
Yes.
level.
Yeah, the problem with flooding is not the melting of glaciers. Glaciers will melt and that changes ecosystems, but like Vlad's saying, that already is accounted for in the water level. But the problem is when the ice that lies on top of land
Oh.
melts, like Antarctica, okay? So the Arctic is mostly frozen water on water, and so that doesn't change. But like Greenland is huge ice sheets on land. When that ice melts, all that water goes into the ocean, increasing sea level. The warmer the oceans are, the more storms we have, the more intense storms, hurricanes, things like that. Why? Because that's the energy behind hurricanes and other tropical storms. The energy that drives those is heat. And as you increase the amount of heat in the oceans, you increase that. Okay?
Is that why when you're trying to show it tenacity of the storm, is that why it's like red or
I don't know if that's why they use red. It's possible. Certain diseases can spread, like I was talking about, like malaria or other mosquito-borne illnesses. I need, hold on. This is kind of a neat way to visualize temperature changes. So what this little animation shows is global temperature monthly over a period of, I don't know, 150 years or so. And you can see the way it works is the line that's being drawn goes around for each year, for each month. And the farther out it gets, the warmer the temperature. So obviously, this line keeps going out farther and farther, okay, because temperature is increasing throughout this time. So if we go back, this is at, Julia?
Is it possible?
Okay, so from 1850, I'm sorry to interrupt. You see temperature as each month goes on, but every year it gets slightly warmer and this line gets farther and farther away from the center. So this is 1.5 degrees Celsius warmer than the starting point. This is 2 degrees. And so this line continues to increase as the Earth gets warmer year after year. What was your question, Julie?
Is it possible to get like an ice age?
There are cyclical periods of ice ages and colder periods and warmer periods, but we have exceeded those normal fluctuations. And, you know, there are some people that are climate change deniers who don't believe in it. Okay? 98% of climate scientists agree that climate change is real and is caused by humans releasing carbon dioxide. These are experts that study this topic for their entire life. But some people refuse to accept the science behind it. But the science clearly shows the Earth warming and it being due to increase in carbon dioxide due to humans. This is a graph of carbon dioxide levels for the past 400,000 years. And so this goes along sort of with what Julia was talking about, okay? Ice ages and so forth. There are changes in carbon dioxide. It goes up and down, and historically it has hundreds of thousands of years. There drops and increases, and when that level drops, that would be an ice age, a cold period. As it rises, that would be a warmer period. So there are natural fluctuations, okay? And you see that. But then you see what has happened in the last few hundred years, okay? And we have just completely blown away these previous prehistoric changes in carbon dioxide levels, and we have reached historic levels here. So the reason for this, the reason carbon dioxide has this effect, it's called the greenhouse effect. The greenhouse effect, I don't know, does anyone have a room in their house with lots of windows and the sun shines in there certain parts of the day? And what happens in that room?
It's hot.
Really hot. Or if the windows are up in the car and it's sunny, it gets really in there really quickly. That's why it's dangerous for pets or children. And the reason is because the glass allows the sun's energy through. But then when that sun's energy is absorbed by, the seats in your car or the carpet or the floor or the earth's surface, it's changed. And that heat cannot escape through the glass. So energy is allowed in, but the heat is trapped by the glass, by the carbon dioxide, and it heats up very quickly. So carbon dioxide allows sunlight in, but then traps heat close to the Earth's surface. It's kind of like clouds. I don't know if you ever noticed this. In the winter, which mornings are the coldest? A cloudy morning or a clear morning?
Cloudy.
Clear. They're both. Clear. Clear mornings are much colder. That's because the clouds, as the Earth absorbs the energy from the sun in the daytime, in the night it radiates that out and releases it. If there are clouds present, what do? They trap some of that heat in, and it's warmer. If it's completely clear, that heat can radiate out and be released.
Wait, in the summer though, it's different, right?
No, same thing as that.
Really?
Yep. Yeah, the question I have.
Wait, yeah. So basically, you know how you said that there's like a hole in the ozone?
Yes.
Yeah, you saw that.
So here's something important for me to tell you. Ozone depletion and climate change are pretty much completely unrelated. So people sometimes confuse the two. They're caused by different gases, really. They result in different things. The hole in the ozone layer, some people think, well, it allows more heat in. It doesn't. It allows more ultraviolet radiation to reach us. So they're sort of two separate issues. Here are some pictures that help you to understand that. This shows sea ice in the Arctic. The white, obviously, being the Arctic. Okay, top of the world. Okay, this is in 1979. Okay, this is 2005. If you notice this area. In 2005, this is open water. It's not frozen any longer. Okay? In this 1979, which is not that long ago, the ice is still forming. So this Arctic ice is melting. It's drastically receding. Here we have another picture. This is a picture taken from the exact same viewpoint of a glacier. Here in 1928, you see the mountains in the background, you see the ice of the glacier, you see here's some land without the ice. In 2004, this glacier has retreated, it is melted, it's now way back here in the mountains, and instead we have a lake. Okay? So obviously a change from this ecosystem to this ecosystem is a drastic change for any species that are adapted to those conditions. And so yes, this has to do with what Vlad said earlier. When this ice here melts, it doesn't change sea level because it's already in the water. It's like an ice cube in a glass of water. When it melts, your water level doesn't go up. This ice here in Greenland, the ice in Antarctica is sitting on top of land. When that ice melts, the water goes into the oceans and water level rises. This is a major problem for coastal countries, for island nations, for coastal cities. Because obviously as sea level rises, it floods the coastal areas. Here are some pictures. So this is if global warming, climate change continues. All the glaciers and ice melted, including Greenland and Antarctica. That would be a significant change, a huge change in sea level. Here's what the coastline of the southeast of the United States would look like. So here's the current coastline. You see obviously Florida. Okay. The new coastline, if all that ice were to melt, would look like this. Florida basically gone. Florida's a few islands. Okay. Bye-bye Disney World.
Wait, what year is this?
This is, it's not a year, it's if global warming continues and all the sea ice melted, you know, that's like a few hundred years probably.
Oh my god, Florida would be gone.
Florida would be gone. And also look at the coastline. Again, if you look at a map of major cities anywhere in the world, people build, major cities are on coastlines, often. Los Angeles, New York, Boston, Charleston, Miami, San Francisco, New Orleans. So major cities are often located there because there's a good, they started there because there's a good source of food in terms of fish and so forth. Shipping, ports to bring in goods and ship out goods. So that's where we've located our cities, and they would be gone.
Wait, so if like global warming kept going like the same rate it is now, in a few hundred years it'd be gone?
Yeah. I mean, I don't know the exact time span. I would have to look that up. But yes,
As
eventually.
long as I'm not allowed to be.
All right.
Yeah, I know.
So again, you see the same sort of thing here, an overall view, and it's the lower lying areas. Notice there's not as many changes in the west coast. I don't know, has anyone ever been to the ocean on the west coast?
Yeah.
San Francisco. Often you have like steep beaches. So you have like cliffs that go down in the ocean. What's it like in Florida?
That's like beaches.
It's super flat, right?
Yeah.
There's not a lot of hills. So that can flood much easier than an area that has a significant change in elevation. Again, South America,
It would look so cool though.
Wait,
Where's Uruguay?
okay? Australia.
what?
Now, the biggest issue,
How to get?
okay, that's Antarctica. That's what the land underneath Antarctica looks like. Okay? That's currently all
So there's
this
gonna be no ice.
covered by. All right. Now, this is especially a problem for like especially parts of like Southeast Asia, which is an archipelago, a series of small islands, Indonesia, where you have hundreds and hundreds of millions of people living that live on island nations, a series of small islands. And obviously islands are some of the first things that are going to flood. And so these island nations, these low-lying countries, it is in their best interest to address climate change. But the problem is it's not really those countries that are the main source of the problem. Who are the main source of the problem? Industrialized nations such as the United States, China, okay? So countries that have large populations that are burning large amounts of fossil fuels. So there are groups and organizations which are trying to address climate change, okay? And that countries get together, they agree to limit their carbon dioxide emissions. But again, that's up to individual governments. There's talk now of the U.S. pulling out of climate change agreements that we have established with other countries, because the current administration does not feel that climate change is a priority. And so when you have this issue, really what we need are countries that produce a lot of fossil fuels and use a lot of fossil to step up and take leadership and set an example for other countries. Because the United States and other industrialized nations became what they are and reached such a high standard of living because we burned lots of fossil fuels. Is it fair of countries like the United States to tell other less industrialized countries, hey, you shouldn't use any fossil fuels if that's going to limit their growth? Those are issues that need to be addressed.
Would Hawaii be all gone?
Yeah. All right. Got a couple of videos I want to show you related to climate change.
Yeah, that's like